Screencast will walk you through how to complete Investigation 1 for Evolution Lesson 5. How does changing the environment that the bacteria are in affect their population? So I have set up my simulation with the parameters outlined in the instructions. And so I'm going to go to the simulation. You can see 10 of each of the 4 variations, reproducing every 1 hour with 100 milligrams of the antibiotic. So I'm going to hit setup, and then I'm going to load up a dose. So we're going to dose them right away, and then make sure that we're good to go. All right, and then we're going to let this simulation run. Until we get to about 100 bacteria in the patient. And then I'm going to transfer it outside and infect a new patient. And then hit pause. So you can see that the bacteria population has kind of changed at this point, even just looking at this initial graph. So we are going to fill in this table in our student activity sheet as we go along. So in patient 2, so in patient 1 we started with 10 of each of the 4 variations and that many bacteria and that distribution of traits. So now that we've infected patient 2, we have 26 purple bacteria. We have 14 green bacteria. We have 18 brown. And we have 3 red, which at this moment in time gives us a total of 61 bacteria. So I'm going to do my quick percentage calculations. Open up my calculator. And I'm going to take 26 divided by 61 times 100 is about 43%. And then 14 divided by 61 is about 23%. 18 divided by 61 is about 30%. And 3 divided by 61 is about 5%. So we should be able to add those up to be about 100%. And then I'm going to go ahead and run the next round of my simulation. So I'm going to set up a dose, and then I'm going to hit go. Transfer outside. Infect a new patient. Pause there so I can capture my data. I'm going to record the numbers 33, 15, 25, and 2. Which gives me a total of 75 bacteria. I'm going to do my calculations again. 33 divided by 75, 44%. 15 divided by 75 is 20%. 25 divided by 75 is 33%. And 2 divided by 75 is about 3%. So You might notice some population or some variations in this simulation are much more successful than others. Namely, the purple looks like it's doing the best so far, and the red looks like it's doing the worst. So let's run this simulation one more time, infect one more person, and see what happens. All right. So we got 32, 7, 21, and 0. All right, right off the bat, we know that is 0%. That gave us a total of 60 bacteria this time when I paused it. So 32 divided by 60 is going to be 53%. 7 divided by 60 is going to be about 12%. And then 21 divided by 60 is going to be about 35%. Now, you might notice that these percentages don't always add up to 100, and that is just because I am estimating my rounding. But now you can see that the purple variation was definitely the most successful, and that if we started with 25 of each of these 4 variations, our population evolved in just 4 patient infections. So with each new environment, we saw some variations being more successful, and we saw some variations being significantly less successful. Now, I will tell you that every time we run this simulation, we might get some slightly different numbers. And if you wanted to try and run this a few times on your own, you can use the screencast and the detailed instructions in your student activity sheet to run it a couple of times on your own.